Hello, all of my grade nines. We are going to move on in our math. We are going to move on to exponent laws today. Hope that you guys had a good weekend. Hope you are enjoying being able to hang out at home. And I hope you are also doing some math because math never stops. Going to keep doing math. So we are going to do exponent laws. Now, if you're not at the part that we're at, that maybe is because you've missed a lesson since being home. So I would suggest you go onto the channel that I have now, the YouTube channel, and you just go and take a look at the playlist called Grade 9 Math. There will be previous lessons posted on there, and it's where I'll continue to post lessons. So if you haven't done the notes from the last one, they are all here, and we went through them together. And we are now moving on to unit 3.4, which is the exponent laws. Inside of your textbooks, this would be on page 70. Where is it? Right there. 73. Okay, so you can go to page 73 and you can find the notes that we are working on, and then obviously the related practice problems that we'll have for these. So what are exponent laws? The best way to figure out what an exponent law is to just look at an example right away. So let's take a look at this example right here. How would we write out the following expression of 5 to the 4 times 5 to the 2? How would we be able to make this easier for us to look at is kind of the idea. And the exponent laws help us to do that. If I write out 5 to the 4 times 5 to the 2, and I do what it says here, which is to write it out as repeated multiplication, I'm going to see something really interesting. 5 to the 4 looks like this. 5 times 5. Good start. 5 times 5 times 5 times 5. So that's the one section. Now what it says is it's also that times 5 to the 2, which as repeated multiplication looks like this. 5 times 5, just 2 times. So we've got 5 times 5 times 5 times 5, that's 5 to the 4 times 5, which is 5 to the 2. Now, is there a way that I can write this right here as a single power? So instead of having to write it 5 to the 4 times 5 to the 2. And there is. If we get rid of the brackets, what this ends up becoming is 5 times 5 times 5 times 5 times 5 times 5. And now all of a sudden that looks like the type of problem that we know how to do, right? Because now if I asked you, if I ignored what I said above here and I said do this part, this repeated multiplication, and turn it into a power, you would count how many 5s there were. 1, 2, 3, 4, 5, 6. So you would write it out as a power with a base 5 and an exponent 6. So that is our final answer of how we can reduce 5 to the 4 times 5 to the 2. Now, where did that come from? Where did that 6 come from? Well, let's take a look at this in terms of words. To multiply powers with the same base, all we have to do is add the exponents. We just add the exponents, and that'll give us the final answer. So think about this as saying 5 to the 4 times 5 to the 2 becomes 5 to the 4 plus 2. So a to the m just represents any numbers. A to the n represents any numbers, except for the a's have to be the same. And then all we have to do is add up the exponents attached to it. So the variable a is any integer except for 0. And the variables m and n are any whole numbers. Make sense? Hopefully. If so, let's move on. If not, you got the opportunity. The beauty of the YouTube video is that you can rewind. You can listen to what I was saying again. Try to see if it makes a little bit more sense the next time. All right. Using the exponent law for the product of power. So let's do an example. Write this expression as a power. So 6 to the 5 times 6 to the 4. So what we get by using our rule up above is we write the base just like this, And then up above, we can add the exponents. So we take the two exponents and we add them together. 6 to the 5 plus 4, that is just 6 to the 9. Now, if you wanted to do this as I did it before, you can write it out as a whole repeated multiplication and then multiply by another repeated multiplication. But this is a little shortcut that we can use, and it should, as long as we're doing it properly, always, always, always give us the right answer. So there we go. 6 to the 9 is our final answer there. Pretty straightforward, right? For its own individual problem. Let's move on. Let's try to make it a little bit more complicated here, like we do. How could I write the following expression of 5 to the 4 divided by 5 to the 2? So not using multiplication anymore, but using division. Doesn't get all that much more difficult. We just remember that if we're adding together for multiplication, we're probably going to do the opposite for division, which is going to be to subtract them. So let's write it out as a repeated multiple. We've got 5 times 5 times 5 times 5 on the top, and then we divide by 5 times 5. Now, what that ends up giving us, if we use what we know about how to divide things, is that some of these 5s are going to end up canceling with each other. Because 5 divided by 5 is just 1. 5 divided by 5 is just 1. And look, now all of a sudden I've gotten rid of everything but just 2 of these. So what I end up with here is 5 times 5. I want to write that as a single power. Well, if I want to write it as a single power, we just take the base of 5 and we raise it to the exponent of however many there are, which is 2. So our final answer is 5 to the 2. So what ended up happening here? In the other one, we ended up doing 4 plus 2. But if we take a look, in this case, we're doing 4 minus 2. 4 minus 2 is giving us our final answer for the exponent of 2. So the exponent law for a quotient of power, quotient is just a fancy math term for dividing, is a to the m divided by a to the n is just a to the m minus n. So they have to subtract each other. Now there's one key here, is that m has to be greater than n in order for this to work. So m has got to be greater than or equal to n for this to work. We'll see some examples like that. But the key is that we are subtracting the exponents. So let's do that. And then we're eventually going to get to a point where we mix them all together. So using the exponent law for quotient of powers, write the expression below as a power, a single power. We have negative 9 to the 10 divided by negative 9 to the 6. All this ends up becoming is we write out our base, which remember, if it's inside the brackets, that negative stays there. So our base is negative 9, and then we just subtract the powers, right, the exponents. So 10 minus 6. Our answer then becomes negative 9 to the 4. Now, this question isn't asking us to evaluate it yet. It's just asking us to write it out as a power. So that's my final answer. But when you eventually get to that point, you can end up solving that and giving me an answer. We'll do that on the next page. Now, let's do a problem where I have to apply both laws at the same time. I have to apply both laws. I've got 3 to the 2 times 3 to the 4 divided by 3 to the 3. All of the bases are the same here. So we're going to add the exponents of the two powers that are multiplied, and then after we're going to subtract the exponent of the power that is divided. So what I get is I'm going to combine these two first, and then I'm going to do that one second. Okay, so what I get is 3 to the 2 plus 4 divided by 3 to the 3. So I just did that part first. Maybe I'll write that down right there. And now I'm going to apply the second part. And what that's going to look like is, obviously, I have 3 to the 2 plus 4, which is 3 to the 6, divided by 3 to the 3, and we end up getting 3. And remember, when it's division, we subtract them. So 3 to the 6 minus 3. And to the 6 minus 3 gives us a final answer of 3 to the 3. And why not? Let's do that. Let's calculate that. Don't put it in your calculators. Use your heads. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So there's your final answer right there. 27. Okay, so they look kind of confusing at first, but if we just take them one step at a time and remember our rules, our exponent laws, we should be able to solve them relatively without too much difficulty pretty often. We just got to remember our rules. I've got 2 more examples I need to do here. Obviously, this is going to get a little bit more confusing because now we have to include orders of operation. So you're going to see multiple things going on with pluses and multiplying, addition, subtraction, division. Okay, so we have to remember to do our order of operations. What that means then, right, is that we do this part first because it's a multiplication, and then we deal with this after. Okay, so we deal with that part first, and then we deal with the other part after. So remember, your exponent law is that we leave this, but this part becomes 6, and it's a multiplication, so we add up our exponents, 3 plus 2. And we'll get 6 to the 2 plus 6 to the 5. And then 6 to the 2 plus 6 to the 5. If we want to actually evaluate that, we can actually just evaluate each power and then add them up. There's no exponent law for this part. So don't get confused and think that now here you have to add the 2 and the 5. No. Now we can use our calculators for this part. We don't for that one. That one's just 36. Plus 6 to the 5. 6 to the 5 is a big number. Should be 7,776. It's a cool looking number. And then we add these up. So our final answer becomes 7,812. Okay? All right, let's take a look at this one. Now, this is even a little bit more confusing. Remember, if we've got 2 sets of brackets, we start at the innermost part of the brackets and work our way out. Okay? So in this case, we're going to do this part first right here. And then we'll do this part. And then we'll do this part. Okay? So what this will end up looking like is we will have negative 10 to the 4. And then inside of this bracket, we have negative 10. And this is a division. So we're going to take 6 and we're going to subtract 4. So 10 to the 6 minus 4. Minus 10 to the 7. Okay. Let's turn this into a number. Then we know negative 10 to the 4 times negative 10 to the 2. 6 minus 4 is 2. Now we multiply these two together. This is a multiplication because they're right next to each other, attached to each other. So we take out our base, negative 10, and we add them up because it's a multiplication. So 4 plus 2 minus 10 to the 7 is still there. So negative 10 to the 4 plus 2, that becomes negative 10 to the 6 minus 10 to the 7. So let's evaluate each of these separately. Remember, if the negative 10 is inside the bracket, we do it inside of the bracket in our calculator. So negative 10 bracket to the 6 should give us 1,000,000. Remember, you don't actually need to put this into your calculator. You can recall that this 6 here means that we're going to have 6 zeros. Okay, remember that from one of our last lessons. Okay, so and then 10 to the 7 should just mean that we're going to have 7 zeros. Now remember, this minus is in front of it, so it just stays there. And then we just evaluate basically the 10 to the 7, which is just 10 million. So we have 1 million minus 10 million. So if I do 1 million minus 10 million, well, that's just like 1 minus 10. I should get negative 9 million. So that is my final answer for part B. So they do get a little bit trickier. There is more steps, but as long as you follow those steps and remember what we've been learning so far about orders of operations, you should be fine. Here are your assigned practice problems for this lesson. Okay, I want you to work on those today and / tomorrow, and I'll be expecting them to be finished, and we'll be moving on Wednesday. Okay, so Wednesday we'll be moving on. Tomorrow, what I'm going to post for you, because we have had a week off, I'm going to post another OLA for you to work on. So I want you to work on that, and then you'll be able to submit it on a Google form a week after that. But it'll probably be 2 weeks because I will obviously not make you submit it during spring break. So during spring break, you'll get that week off, and then you'll have to submit it the week back. All right, so I hope that helped. If you have any questions, remember to just leave the comments in either the YouTube section, or you can email me. People have been emailing, that's great. Or you can comment on the Google Classroom. I noticed that some of you have been doing that, however, not all of you. So I would like you to try to get as involved as you can. This takes both of us to make this work, all right? So make sure that you're being involved as well. All right, we'll talk to you later.